Right now, the sun is shining on your skin. You can feel it, warm, steady, familiar. You have felt it every day of your life. And because of that, you have made a dangerous assumption. You have assumed it is safe. It is not. The sun has already destroyed this planet once. It nearly did it again in 2012, and most people never heard about it. And right now, as you watch this, it is getting brighter. Not in a way you can see, but in a way that will eventually boil the oceans off the face of the Earth. By the end of this video, you will understand 3 things. How the sun killed almost everything alive on this planet, how close it came to ending the modern world, and what it is slowly, quietly building toward right now. Let's start with what the sun already did. 2.5 billion years ago, Earth did not look like Earth. There were no trees, no animals, and no oxygen in the atmosphere. The sky was orange with methane, and yet that faint sun was enough to keep the planet warm, because methane, a greenhouse gas far more potent than carbon dioxide, was trapping heat like a blanket around the world. Then, something changed. A group of microscopic organisms called cyanobacteria evolved the ability to photosynthesize. They began flooding the atmosphere with a gas that had barely existed before, oxygen. To us, oxygen means life. To the organisms that dominated early Earth, oxygen was poison. It reacted with their cells, and it destroyed their metabolisms. Scientists call what happened next the Great Oxidation Event. Others call it the Oxygen Holocaust. It was Earth's first mass extinction, and it was driven by a waste product of photosynthesis. But the sun made it worse, far worse. As oxygen accumulated, it began reacting with the methane that was keeping the planet warm, converting it into carbon dioxide and water. Carbon dioxide is a much weaker greenhouse gas, and the thermal blanket disintegrated. And with the sun already burning at only 70% of its current power, the math became catastrophic. Global temperatures collapsed. Ice sheets advanced from the poles to the equator. The planet froze almost entirely. Scientists call this the Huronian glaciation. It lasted over 100 million years. Earth became a snowball, locked in ice, with a dim sun overhead that could not melt it. The sun's ultraviolet radiation was simultaneously splitting water vapor in the upper atmosphere, breaking it into hydrogen and oxygen. The hydrogen escaped into space, gone, permanently. The sun did not need to explode to devastate this planet. It just needed to interact with the wrong chemistry at the wrong time, and it did. But that was billions of years ago. Surely, we're safe now. In 2012, physicist Fusa Miyake was studying the tree rings of ancient Japanese cedars when she found something that should not have been there. There was a sharp spike in radiocarbon that dated to 774 AD. The levels were so extreme, they suggested a burst of cosmic radiation roughly 10 times more powerful than the largest solar storm in recorded history. She had discovered the fingerprint of a solar superflare. Since then, 9 of these events, now called Miyake events, have been identified in tree rings and polar ice cores spanning the last 15,000 years. The largest occurred 14,300 years ago, detected in subfossil trees buried along the Druze River in the French Alps. That storm was approximately twice the size of the 774 AD event, and at least 80 times more powerful than anything in the modern record. We have never directly observed a Miyake event. We do not know what causes them. We do not know how to predict them. Now consider what we do know. The largest directly observed solar storm was the Carrington event of 1859. A coronal mass ejection reached Earth in just 17.5 hours, roughly 4 times faster than normal. Auroras lit up the sky as far south as the Caribbean. The night was so bright that gold miners in the Rockies began cooking breakfast at 1 in the morning, convinced the sun had risen. Telegraph systems across Europe and North America sparked, shocked their operators, and caught fire. That was 1859. The world ran on telegraph wires and steam engines. On July 23, 2012, the Sun fired a Carrington-class storm directly through Earth's orbit. Earth was not there. We had moved past that point in our orbit just 9 days earlier. NASA Stereo. A spacecraft recorded the blast. Daniel Baker at the University of Colorado analyzed the data and concluded that if it had hit Earth, the resulting geomagnetic storm would have been comparable to or stronger than the Carrington event. A joint study by Lloyd's of London estimated the damage to the United States alone at $600 billion to $2.6 trillion. Recovery time, according to researchers at China's State Key Laboratory of Space Weather, would have been 4 to 10 years. We missed a civilization-altering event by 9 days. Most people never heard about it. But even these storms are not the real threat. They are sudden, violent, visible. The real danger is something you cannot feel at all. The sun is getting brighter. It has been getting brighter since the moment it formed, 4.5 billion years ago. It increases in luminosity by roughly 1% every 110 million years. That sounds negligible. It is not. The sun is already 30% more luminous than it was when life first appeared on Earth, and that slow brightening is a death sentence. In approximately 1 billion years, the sun's output will be 10% higher than it is today. A study published in 2013 in Nature by a team at the Laboratoire de Météorologie Dynamique found that a 10% increase is the tipping point. Earth's atmosphere will enter what scientists call a moist greenhouse state. The oceans will begin to evaporate. Water vapor will flood the atmosphere, and because water vapor is itself a greenhouse gas, it will accelerate the warming. The sun's ultraviolet radiation will then do what it did billions of years ago. It will split the water molecules in the upper atmosphere, allowing hydrogen to bleed into space. The oceans will not just evaporate. They will be permanently dismantled, molecule by molecule. Earth will become a desert world, then a furnace, then something resembling Venus. And the sun still won't be done. In approximately 5 billion years, it will exhaust the hydrogen in its core and begin expanding into a red giant, swelling to roughly 256 times its current size. According to Schroeder and Smith, writing in the monthly notices of the Royal Astronomical Society, the sun will engulf Mercury, then Venus, and almost certainly Earth. Even if Earth's orbit drifts outward as the sun loses mass, tidal forces from the swollen star will drag it back in. Earth's surface temperature will exceed 2,000 degrees Celsius. The planet that orbited this star for billions of years will be vaporized by it. Here's what makes this different from Jupiter, from black holes, from everything else in space that can kill you. The sun is the reason you're alive. The same ultraviolet radiation that stripped early Earth's atmosphere also helped build the ozone layer that protects you right now. The same energy that will boil the oceans in 1 billion years is currently feeding every plant, powering every food chain, warming every ocean current that makes this planet livable. The sun is not the villain in some distant cosmic drama. It's the thing you depend on most, and it's the thing that will eventually take everything away. We exist in a window, bright enough for liquid oceans, dim enough for stable ice caps, calm enough between superflares to build civilizations. That window opened billions of years ago, and it is, right now, slowly closing. The sun that rose this morning is the same sun that froze the planet, the same sun that fires invisible superflares into the dark, the same sun that is quietly, imperceptibly getting brighter. It gave us everything, and it has already started taking it back. If this gave you a new perspective on the star we thought we knew, consider subscribing. I'll see you next time.